4 billion years. That's how long life has been fighting, adapting, and clawing its way across this pale blue speck of rock we call home. And in all that time, through mass extinctions, ice ages, volcanic winters, one group of animals became so massive, so dominant, so inevitable that we assumed nothing could erase them. Then one day, they were just gone. No slow fade, no warning, just silence where giants once walked. And the terrifying part? We still don't fully know why. This is the story of the sauropod hiatus, and it might be the deepest unsolved mystery in all of paleontology. Imagine standing in what is now Utah, about 99 million years ago. The air is thick, humid, warm, almost suffocating by modern standards. Ferns carpet every surface, conifers tower overhead, and the ground beneath your feet, it shakes. But not from an earthquake, from footsteps. Except, here's the thing, the footsteps never come. Because the animals that should be making them aren't there. For millions of years before this moment, you would have heard them. You would have felt them. The low, rumbling percussion of 50, 60, maybe 80-ton bodies moving in slow procession through the landscape. Long-necked, small-headed, impossibly massive. Sauropods were the undisputed kings of the Jurassic world. They were everywhere. Every continent, every environment. A single fossil site in Colorado, the Morrison Formation, preserved over 24 distinct species living side by side. And then, the Cretaceous began. And in North America and Europe, they vanished. Not all dinosaurs, not even most dinosaurs. Just the sauropods. The hadrosaurs were still there, honking and herding in enormous flocks. Ceratopsids were charging across floodplains. Tyrannosaurs were beginning their long, terrifying rise. Life, in other words, went on perfectly fine. But where the longnecks had walked, there was only absence. For 30 million years, North America had no sauropods. To put that in perspective, 30 million years is 1,500 times longer than the entire Ice Age. The one with mammoths and saber-tooths that we already think of as ancient history. And the truly maddening part of this disappearance, it wasn't global. In South America, Africa, and Asia, sauropods were thriving, exploding even. Some of the largest animals to ever live on land evolved during the exact same window that North America had gone completely dark. It's as if an invisible wall appeared across the planet. On one side, giants. On the other, nothing. Why? How? To understand the fall, you have to first understand the peak. Imagine walking through a Jurassic forest 155 million years ago. Not Utah, not the Serengeti, but a world with no parallel in modern experience. The trees are enormous, but the animals make the trees feel small. Sauropods had taken over after a global warming event early in the Jurassic reshuffled the ecological deck, and they never looked back. At the Morrison Formation alone, at least 24 species of large to giant sauropods coexisted. Brachiosaurus, Diplodocus, Camarasaurus, Apatosaurus. These weren't just big animals filling a niche. They were the dominant megafauna of the entire planet, the most successful large herbivores Earth had ever produced. But then, the Jurassic ended, and something happened at the boundary that history has almost completely forgotten. It's called the Tithonian extinction. We don't talk about it much. It doesn't get the cinematic treatment that the asteroid gets, or even the Permian extinction. But roughly 145 million years ago, the world cooled, sharply. Some researchers think volcanic activity triggered it. Others point to 3 large impact craters, each independently dated to this exact window, scattered across different parts of the globe. Whatever the cause, it hit sauropods disproportionately. Groups that were once abundant collapsed almost overnight in geological terms. The group survived, but it entered the Cretaceous wounded. In North America specifically, only two groups made it through: the Brachiosaurids, the last echoes of Jurassic dominance, and a lesser-known Titanosaur lineage. And even they were rare. Ghost animals. Fossils from this period are sparse enough that finding even a fragment makes headlines. And then, around 98 million years ago, even those last holdouts disappeared. 30 million years of silence. But why did they disappear when so much else survived? Researchers have proposed three culprits, and the most compelling answer is that all three acted together, like a perfect storm. The first, the Western Interior Seaway. During the Cretaceous, a massive inland sea split North America clean in half, stretching from the Arctic all the way to the Gulf of Mexico. This wasn't a river, this was an ocean, right through the middle of a continent, and it didn't just divide the land, it drowned it. Enormous swaths of low-lying coastal habitat, exactly the kind of habitat that supported sauropods, disappeared beneath the water. The second culprit, competition from hadrosaurs. Here's where it gets genuinely strange and a little brutal. Hadrosaurs, the duck-billed dinosaurs, were rising fast during this same window. And while you might assume a hadrosaur and a sauropod wouldn't compete, one was a high browser, the other a low grazer. The real conflict happened at a specific point in sauropod life history: juveniles. A young sauropod, newly hatched, wasn't tall. It was eye level with a hadrosaur. And hadrosaurs had something extraordinary: complex dental batteries, hundreds of tightly packed teeth, capable of processing vegetation with a precision and efficiency that no sauropod could match. In a landscape already shrunk by rising seas, where food was finite and contested, juvenile sauropods may simply have been outcompeted before they ever had the chance to grow into their size advantage. And the fossil record timestamps this almost perfectly. The last North American sauropods and the first North American hadrosaur ancestors appear in almost exactly the same geological horizon. The third culprit, Europe. Europe during the Cretaceous wasn't a continent in the way we'd recognize. It was an archipelago, a scattered chain of warm subtropical islands surrounded by rising seas. And on islands, the rules change. Populations become isolated. Resources are limited. Island ecosystems are fragile in ways that continental ones aren't. Sauropods on these European islands faced the same double threat: shrinking land, expanding competitors. The hiatus there was shorter, but the pattern was identical. The same conditions played out independently on opposite sides of the Atlantic, with the same result. And while North American and European sauropods were disappearing, on the other side of the world, the titanosaurs of South America were entering their golden age. Argentinosaurus, potentially 80 tons, was walking the Patagonian plains. Patagotitan, Dreadnoughtus, Bruhathkaiosaurus. While the north went dark, the south went enormous. And then, just as suddenly as they had vanished, they came back. About 68 million years ago, near the very end of the Cretaceous, a single sauropod reappeared in what is now the American Southwest. Its name was Alamosaurus, a titanosaur, a migrant, almost certainly, that had pushed northward from South America as the Western Interior Seaway finally, slowly began to retreat. And it wasn't small. Estimates put Alamosaurus at somewhere between 30 and 80 tons, potentially making it the largest animal to ever live in North America, despite also being the last. Think about what that means. Every famous North American dinosaur, Triceratops, T-Rex, Parasaurolophus, lived in a world with no sauropods. These animals that dominate our imagination of the Jurassic were completely absent from the world of equally famous Cretaceous icons. The crossover never happened. And when Alamosaurus finally returned, it had maybe 2 million years. 2 million years before the asteroid hit, before the skies darkened, before the non-avian dinosaurs ended. Sauropods came back just in time to die. There's something almost unbearably poetic about that. These animals, the largest to ever walk the Earth, survived one extinction at the Jurassic boundary. They survived rising seas. They survived competition and isolation and the slow erosion of their world. They endured a 30 million year absence and somehow found their way back. And then they ran out of time. Here's the question I want to leave you with, and I want you to actually sit with this one. If the asteroid hadn't hit exactly when it did, if Alamosaurus had been given another 10 million years, could sauropods have re-established themselves in North America? Could we have seen a second golden age of giants? Or were they already too weakened, too few, too late? Because the hadrosaurs were still there? The competition hadn't gone anywhere. The world that had nearly erased them once was still the same world. Drop your answer in the comments, because the sauropod hiatus may be solved in the broad strokes, but the finer details are still being worked out. And honestly, I think the full story is stranger than we've yet imagined. Until next time.